You're listening to the N2K Space Network.
Our friends at the Beyond Earth Institute are hosting their annual symposium in Washington, D.C. on November 1st and 2nd. The theme this year is LEO to Lunar to Living Beyond Earth. You can join senior leaders from across industry, government, and the international community to examine the policy challenges impacting the rapidly evolving space ecosystem. Leaders like Michelle Hanlon, Lieutenant General John Shaw, Frank White, and more. Register for the event at beyondearthsymposium.org or space.n2k.com/beyondearth. We hope to see you there. The U.S. federal shutdown has been averted, for now. So now there are 43 days and counting for the Senate and House to figure out a long-term solution to their funding. Meanwhile, commercial spaceflight companies can breathe a sigh of relief. The continued resolution also extended the learning period for human spaceflight until January 2024.
T-minus 20 seconds to LOS egress. Go for deploy.
Today is October 2nd, 2023. I'm Maria Varmazes, and this is T-minus. The U.S. continuation resolution extends the learning period for commercial spaceflight companies. The IAC opens in Baku. NASA contracts with SpaceX for weather satellite missions. And our guest today is Tim Franta, Vice President of Development for Starfighters Space, on the future of supersonic flight. Let's take a look at the intel briefing for this Monday. Little doubt today about what our top story would be. The specter of a U.S. government shutdown has been pushed aside, at least for a few more weeks, in a squeaker on Saturday night. In case you missed it, in last Friday's episode, we briefly chatted with Dan Dumbacher, who is the executive director of AIAA, about the possible repercussions of a federal shutdown on both space and the FAA commercial space learning period. The nutshell? Wouldn't have been great. So we're all glad that the worst-case scenario did not come to pass. Still, we're nervously eyeing November 17th now, as that's the next funding deadline. The learning period has received a 3-month extension until January 1st, 2024, under the continuation resolution. Today marks the opening of the 74th International Astronautical Congress and get-together. This year's conference is being held in Baku, Azerbaijan. We'll be watching the conference for news and announcements, and we'll bring them to you throughout the week. And if you have news from the conference that you want to share with us, you can email us at space@n2k.com to get featured in the show. On to some news now from NASA, and we're starting with a positive update on the New Horizons mission, which we discussed with Alan Stern on our show last Wednesday. Following a petition led by the National Space Society and calls from former NASA leaders, the U.S. Space Agency has announced an updated plan to continue New Horizons' mission of exploration of the outer solar system. Beginning in fiscal year 2025, New Horizons will focus on gathering unique heliophysics data, which can be readily obtained during an extended, low-activity mode of operations. NASA has selected SpaceX's Falcon 9 rocket to provide the launch service for the agency's TRACERS mission. Now, TRACERS stands for Tandem, Reconnection, and Cusp Electrodynamics Reconnaissance Satellites, which will study space weather and how the sun's energy affects Earth's magnetic environment, or magnetosphere. The TRACERS mission is led by the University of Iowa, with partners at the Southwest Research Institute and Millennium Space Systems. The mission has a target launch readiness date of July of next year. NASA has also selected 4 small Explorer missions to conduct concept studies aimed at expanding knowledge of the dynamics of the Sun. The missions will also look at related phenomena such as coronal mass ejections, aurora, and solar wind to better understand the Sun-Earth connection. Funding and management oversight for these mission concept studies is provided by the Heliophysics Explorers Program, which in turn is managed by the Explorers Program Office at NASA's Goddard Space Flight Center. And you can read about the selected studies by following the link in our show notes. Intuitive Machines has opened its Lunar Production and Operations Center at the Houston Spaceport in Texas. The completed facility is ready to support each of Intuitive Machines' 3 NASA-awarded missions. Intuitive Machines says the Lunar Production and Operations Center serves as the pivotal bridge between the Earth and the Moon, enabling sustainable, safe, and efficient human and robotic space exploration. Intuitive Machines confirmed its first mission lunar lander, Nova-C, will be shipped from the new facility in the coming days ahead of its upcoming launch. The mission to deliver NASA and commercial payloads to the Moon's South Pole marks the first attempted lunar soft landing by the United States since 1972. Speaking of the Moon, the lunar night has set at the Shiv Shakti point, dimming hopes of reviving Chandrayaan-3's Vikram lander and Pragyan rover. The European station in Kourou and ISRO's telemetry, tracking, and command network in Bengaluru had been attempting to revive the duo. The lunar night marks the end to the Indian Space Research Organization's mission at the lunar South Pole, but the space agency is still buoyed by the overall success of Chandrayaan-3. And hot on the heels of India's success on the Moon, the country is now setting its sights once again on the red planet. Indian news sources are reporting that the country is planning a second Mars orbiter mission, or MOM-2, which would carry 4 payloads. According to the mission document, payloads will include a Mars orbit dust experiment, a radio occultation experiment, an energetic ion spectrometer, and a Langmuir probe and electric field experiment. But there's no details yet on when MOM-2 will launch. And this next story is definitely appropriate for the Mid-Autumn Moon Festival, as China is setting its plans for its next lunar mission. First up is a launch of their newly developed relay satellite Queqiao-2, which means Magpie Bridge 2. The China National Space Administration says it plans to launch the vehicle in the first half of 2024 to support communications for its next lunar mission, Chang'e 6. That mission will also carry payloads from international partners, including France's Dorn radon detection instrument, the European Space Agency's negative ion detector, Italy's laser retroreflector, and a CubeSat from Pakistan. And congrats to China's Chang'e 5 mission team, who have been honored by the International Academy of Astronautics for their work in returning lunar samples from the Moon. The team won laurels for team achievement, which is the highest award presented by the IAA at the annual gathering ahead of the IAC in Baku. The UK Space Agency is inviting applications for UK support for the European Space Agency's Competitiveness and Growth Program. This call is open to all commercial technology, product, and service developments within satellite telecommunication in the UK. More details can be found following the link in our show notes. That concludes today's intelligence briefing. But as always, you'll find links to further reading on all the stories that we've mentioned in our show notes. We've also included an op-ed from Skyrora's CEO on creating a new launch hub in Scotland. You'll find all the links and more at space.n2k.com. Hey T-Minus crew, every Monday we produce a written intelligence roundup, and it's called Signals and Space. So if you happen to miss any T-Minus episodes, no judgment, it happens. This strategic intelligence product will get you up to speed in the fastest way possible. It's all signal, no noise. You can sign up for Signals and Space in our show notes or at space.n2k.com. Our guest today is Tim Franta. Vice President of Development for Starfighter Space. Tim started our conversation by giving me an explainer on what the company does.
We are a very unique company. We have a fleet of F-104 aircraft, which, even though they were designed in the 50s, still hold most of the world records for speed and altitude. And from that, we had the capability of being able to test payloads for space at high altitude and high speed. And also this next year, we'll be launching rockets to suborbital space.
So a fleet of starfighters is such a cool idea just on its own. Like, that's really cool. And they are supersonic. And I know, and I was looking at your company website, and it sounds like hypersonics is also something that Starfighter Space is looking at for sort of the near to long term. Can you tell me a little bit about that?
Sure. There's a couple of reasons for that. One, the U.S. has fallen behind in hypersonic development. Pretty much in 2017, we were ahead. And then China and Russia have caught up and surpassed. As a matter of fact, Russia has fired at least 5 hypersonic missiles into the Ukraine, one of which was specifically targeted for the Ukrainian Air Force spare parts. So it is very crucial. And the reason why hypersonics is so dangerous is you don't have time to respond. They go so fast. They go at least a minimum of 5 times the speed of sound. And so you do not have time to react. Your first is usually the impact is when you know it hit. So for starfighters, we can fly to Mach 2. We're the only commercial fleet in the world that can fly sustained Mach 2. Usually when we show the list of entities that are capable of that, it's like China, the United States, France, Great Britain, and about number 8 or 9 is starfighters. So it's a very unique capability. So even if we launch a relatively slow rocket, a Mach 4, Mach 5 small suborbital rocket, if we launch it through the atmosphere, because we're already going Mach 2, it'll go greater than Mach 5. So therefore, we're a test bed for a hypersonic platform. One of the big differences between us and other companies, everyone's concerned about launch, and launch is important, but we also consider ourselves a test bed because we can fly the profile of most rockets the first 30 seconds to a minute of launch for high altitude, high G. I mean, we can be at 30,000 feet and really close to 30 seconds. It's quite a flight. So we can test transponders, termination flight systems, opticals, whatever they need for a rocket. So we're unlike other companies because we'll test components and units of bigger companies. And because it's much cheaper to fly an F-104 and test it before you send up on a $250 million satellite.
Yeah, I was going to say that cost savings is amazing. And that is certainly a really key differentiator for you, and certainly something that jet launch differentiates itself in general. So I'm very curious about, so you mentioned a few use cases as you're thinking about the long term for the different types of payloads. Any thoughts on sort of ideal use cases there, or what you're looking at specifically?
We can test most any component of a payload. And another thing that separates us from other companies is that when we launch to suborbital space and eventually to low Earth orbit, we are at this small size because the F-104 can only carry so much payload. So most companies had the capability of doing that, such as Rocket Lab and SpaceX. People forget there was a Falcon 1. That was so long ago, but there was a Falcon 1. Everyone has gone who had small payloads, have increased to medium at the minimum, and now Starfighters and Rocket Lab bunch them all together. But we could fly single-use payloads. A lot of that is for testing, again, because it's much easier to test and much cheaper to test than to put all your eggs in one basket. But it's the same type of payloads, optical, testing a thruster. It's the same thing everyone else does. Imaging is very important. And also for us, we can get some pretty good times for zero G. So on our first vehicle, hopefully in the not too distant future, you'll get about 15 minutes of good zero G. While Elon is making the biggest rocket to get to space, we are literally making the smallest rocket to get to space. And the market can cover that. And there's reasons to have the smaller end. A lot of people thought the limitations of the F-104 was a burden. No, it's an envelope. And it is great to know the frame you can work with, how much mass, how much speed you have.
I would love to hear a bit about like the long-term vision for the company as well, like how you hope to grow and maybe other ambitions that are going to get folded in there.
We are going to stay lean and mean. because we fly. We are the flyer launch company. So we have a lot of strategic partners, and so we will stay small. But one of our growth is when we have our first successful launch, or actually we have our first 3 successful launches for the SELA. And by the way, SELA stands for Starfighters Innovative Launch Alliance. And the reason we call it Launch Alliance is because we designed for the military, for commercial, for civil, and more importantly, the A at the end is for academic. It's been too expensive for a lot of universities to fly, or they have to wait a long time, or fly in a profile they're not thrilled with because they're a secondary payload. We can design pretty much a cost-effective way for universities and nonprofits. And also, we're a very good price for entrepreneurs. So the one thing we'll do to grow is we love that Rocket Lab and SpaceX have created the business model. So we will do economies of scale too. So once we have our first 3 successful launches, we'll order 6 rockets. So we get the economies of scale. And hopefully we'll follow what Elon did. He said, we'll fly once a quarter, we'll fly once a month, we'll fly once a week. Our growth pattern is pretty much the same. Now, one thing about Starfighters, we technically could be able to launch twice a day.
That reusable first stage is handy.
Yes, extremely. So the other thing with our plans to grow is we're already located at the Kennedy Space Center. And as a matter of fact, when we fill out the FAA paperwork, I just had to write in 3 numbers because launch site, it was like 08-018. And I was done with that part of the application. So the other great thing about us, where we can stay lean and mean, is I can just pick up the phone and order liquid oxygen. I can pick up the phone and order methane. I can pick up the phone and order a specialized crane by being at the Space Center. So it's already, we have huge cost savings just by that capability. We're at the RLV hangar at the old shuttle landing facility. It's now called the Launch and Landing Facility. So we have access to $1 billion facility, and we just pay a $500 landing fee.
Not everybody can say that, that's for sure.
And there's some huge advantages having one of the world's longest runways, because we only get, if we're at a normal airport, 10,000 feet, we would get about 5 landings on the tires. But because the runway is so long, we just coast and we get about 7 landings on the tires.
Nice. It's really neat what you guys are doing. And I love that the phrase lean and mean is coming up a lot, because it's really nice that you have that vision and that, that you found that sweet spot. And certainly what you all are doing, it makes a lot of sense. So you mentioned the SELA. I would love for our audience to learn a little bit about what that is, if we can give them sort of an intro into that.
Sure. So if any of you look to see what the SELA is, it looks very much like an AMRAAM 120. And the reason for that is because we're smart people. If there is a well-known air surface that has lots of history, use it. So it does look like AMRAAM 120. And it had been deployed off the F-104. So it looks very similar to AMRAAM 120. And so it would get, our first vehicle will get us to about 117 kilometers and a nice 15 minutes of microgravity. It's to demonstrate all the problems, work out the kinks. Now, we will have perpetual customers for the SELA 1. It's not like we'll do a SELA 1 and get rid of it. So we have some customers who only need 15 minutes of microgravity, need to go up 117 kilometers. SELA 2 is the bigger one, and it's 49% bigger. And we're working out now the holy grail is the mass frac of how much fuel, how much payload, and how much speed the F-104 and altitude can go. So I cannot say precisely because we are not in final design yet, but we're working on the mass frac. And of course, we want to optimize it to go as high and fast and low Earth orbit as possible. But I can share something with you. We will fly out the fleet in about 2035. That's its life expectancy. And we have all the spare parts and everything. But my boss, Rick Svetkoff, the president of the company and the lead test pilot, firmly believes, and the market indicates, there will be a commercial supersonic aircraft. So we will be developing whatever our next vehicle after that is for the follow-on. And we're not going to pick a winner or loser. I mean, there's certain ones that are further ahead, but there will be if not, there could be 2 commercial supersonic vehicles. So you're all smart people in this business. You can figure out, if there's a commercial vehicle, they'll be able to carry more mass. So we're in the black because we don't reinvent things. If it's available commercially, we buy it. I have fights with people. Why are you redesigning a valve? This valve's existed for 50 years and it works. We're not going to redesign it. So we use other services. And if someone's developing another supersonic commercial vehicle, why would we not use it?
We'll be right back. Welcome back. And it's the Mid-Autumn Moon Festival in Chinese culture at the moment. And over the weekend, it was also the Moon Viewing Festival in Japan. So let's take a look at what's going on in Japan in the moment. And, what's that? Giant robots? If you happen to be going to the Japan Mobility Show later this month and have $3 million burning a hole in your pocket, you can place an order for your very own 4.5 meter or 14.8 foot tall human-piloted robot called the Arcax. Built by Tsubame Industries of Tokyo, yes, the Arcax is a real working 3.5-ton mech suit. Yes, there is a cockpit where you can sit and control the whole thing. Yes, you can get in the robot. Not that someone needs a justification to build giant robots in my book, but since people asked, Ryo Yoshida, chief executive of Tsubame Industries, says his mechs could be handy for disaster relief or even space exploration. If you want to imagine this mech on the moon, think less giant leap for a machine and more roving. We are not yet at walk cycles, so no anime-style dramatic leaps for you. Instead, the Arcax is wheeled. But hey, it also has 2 modes, an upright robot mode and a lowered vehicle mode, so you can rove at a respectable for a rover speed of 10 kilometers an hour. Still, let's not bury the lead. It transforms. You could say it's a robot in disguise. And for the mech of your dreams, you can, of course, customize the paint job. Admittedly, it might be a while before we figure out how to get a 3.5-ton mech to the moon. It's kind of heavy. But in the meantime, on Earth, you can choose to make your mech sapphire blue, pearl white, spark red, Atlantis green, or midnight purple. Decisions. That's it for T- for October 2nd, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We'd love to know what you think of this podcast. You can email us at space@n2k.com or submit the survey in our show notes. Your feedback ensures that we deliver the information that keeps you a step ahead in the rapidly changing space industry. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K Strategic Workforce Intelligence optimizes the value of your biggest investment, your people. We make you smarter about your team while making your team smarter. Learn more at n2k.com. This episode was produced by Alice Carruth, mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazis. Thanks for listening. We'll see you tomorrow.
T-.